So in this video, we are going to take a look at booting up the 3000. And what we have here, I've already powered on the CPU. We see the status activity light here. A indicates that the system is idle right now. The other important light for us to look at while we're booting up the system is this I/O activity light, because the system's going to go out here to the disk drive and pull in the MPE operating system. And we only have one spindle on the drive, so we just have one indicator light lit up right now. This will blink when the CPU is accessing the disk, and then we'll see activity here and I/O activity reflected there. So I've got the system all turned on. I haven't powered up all the other peripherals because we only need the system disk and the CPU to actually boot up the system. In another video, what I'll do is actually show booting up with all the peripherals and some of the things you can do with the firmware tools. So we see on the console that post has passed here, so our power on self-test is good. And we have a terminal interface on channel 1 and channel 13, which is in the expansion cabinet, this E5 here. And then on channel 4, we have a peripheral interface controller, and that's where we're going to find our disk drive is connected. Actually, why don't we go ahead and just take a look at that. So if we go into the test submenu, we see here we have a command. We're not going to worry about these commands here, called IO map, and I'm just going to show IO map. And this is going to go out and identify all the peripherals which are connected to the system and powered up. So the firmware goes out through the CPU, through the IO system on the CPU, and queries all these devices, or places devices could be. Hello, is anyone there? And if you are, identify yourself. So we see the only thing we have is on channel 4, device number 4 is a generic HP peripheral device. That's actually our disk drive, so we're going to boot off of that. So let's go back to the root menu, and for MPE, and again, these are firmware commands in the CPU. Why are you hanging up here? Okay, sorry, my screen recording software, I think, is interfering with my terminal emulation software. We're going to do this start command. I'm going to tell it start from channel 4, device 4, which is our disk drive. And we should see the disk light is starting to blink, and we should get some I/O activity. And yep, there's something going on here. And so now the boot code, or the bootloader, has been loaded off of disk, and it's asking us here at the console, do we want to do a warm start or a cool start? And in very generic terms, warm start recovers spool files and other temporary files. Well, not sure about temporary files, session temporary files, but temporary files that are on disk. Cool start is, I'm just assuming I don't want to keep any spool files that are out there. What we're going to do is, we're going to do a cool start, because a cool start is going to let us make some changes. And just for grins, we're going to go in and change the size of a system table to improve the performance of the system. So if we say we want to do a cool start, yes, we want to do changes. We don't care about seeing a load map. Our memory size, we don't want to change that. It's still 2 megabytes or 1024 words. Remember, this is a 16-bit mini computer, so it has 2 bytes per word. I/O configuration changes. We're not going to do that, but just to show you what that looks like. Again, here's the I/O map, and this is similar to what we did with the firmware earlier, where the system went out and identified all the devices that were on the system. when we do that now, this actually is not using the firmware version of that I/O map code. It's actually the software that's running in the boot code. So we're seeing some more detailed information here. So earlier, where we just saw HPIB device, we now see 2200A disk drive. So it gives us a little bit more specific information there. List I/O devices. This will tell us what our current I/O configuration is on the system. And I'm just not going to go into a lot of detail about this, except to say that what I've done on this system is I've configured what's basically a minimal system. And you know what we can't do though? Let's go in and add another terminal device, because we can have up to 16 terminals or modems on the system. So I'm going to go ahead and add an LDEV24. So after 23 here, I'm going to add 24. This device defaults, we don't care about that. Highest DRT, so that's how big our device reference table is going to be. 127 is probably okay for a system that's this size. Electrical device number. Okay, so here's where we can go in and make changes to this table that's up here. So what we can do is we want to add LDEV24, and the device name, there's a way to kind of there's a template in this boot code that we can kind of use to kind of fill in all the extremely gory and very error-prone details of configuring devices in. So what we're going to do is we're going to use that template. And the template for terminal devices on this particular piece of hardware with the particular terminal controller that we have is called HP Term ATP. So that's HP Terminal. ATP stands for Advanced Terminal Processor. And so we're going to hit that. So what it's going to do is it's going to just kind of default or show us defaults for these devices. And this is exactly what we want. So device reference table entry number 8, yes. You see all these devices up here. There are all these other terminals starting with the console. 21, 22, and 23 are all in DRT8. Unit number 2. Oh, actually what it's doing is it's filling in a gap here between unit 1 and 3. That's fine. We can do that. We don't care about that. Channel. So we're just going to take defaults. I'm just going to keep hitting the enter key, and we're just going to take defaults for all these here. Okay. Yes, we can enter jobs. We can do data. MPE has this kind of goofy data tape concept, which is a holdover from the days when you had card readers and real tape drives that you could do data entry in. You can still do that functionality. Okay, so now we've configured another terminal. We've configured another terminal as electrical device 24. It's asking us, do we want to configure another one? I'm just going to hit enter, which is no. Max spool files 50, that's fine. List I/O devices. So let's just take a look, and we should see an LDEV24 at the very end of the list. So LDEV1 is our system disk. LDEV6 is our line printer. 7 is our tape drive. 10 is our pseudo device that we have for submitting batch jobs. And 20, 21, 22, 23 are our terminals we had before, and then we see now we have LDEV24. So we now have 5 terminals configured on the system. We have our special terminal 20, which is always the console. That's what we're working on right now, and then the rest of our terminals are just regular users can log into. Terminal type changes. Nope, we don't want that. I'm going to hit enter. So I'm just going to hit enter for all these things we don't want to change. Okay, after this point, it's if we say no here, or just take the default, which is no, then we're not going to be able to make any more I/O configuration changes. And what it's going to do is it's going to start building system tables and loading drivers and so forth. But first, it's going to ask us, no, we don't want to do any disk volume changes, no virtual memory. No. Whoops. Oh, I did want to do system table changes. That's okay. We can do that when we do cut a system tape. Recover lost disk space. So if your system crashes, you know, you have a bunch of users on the 3000, and these 3000 systems could have hundreds and hundreds of terminals connected to them, with people just banging away doing real high volume, heavy duty transaction processing. And you know, they were really good with uptime. I mean, that was the thing that was one of the key selling points on the HP3000 was, I mean, the thing just never went down. But you might have hardware failure. You could occasionally have a software system abort, power failure, that kind of thing. So when that happened, you could lose disk space, which meant that the data structures which are used to keep track of information on disk could get out of sync. The 3000, so the thing is, the 3000 had a journaling file system, and it may have been one of the first commercial time-sharing systems to have a journal file system. But so it could do automatic recovery. We're not going to do that here because we haven't had any system crashes. But anyway, as part of the startup, you could go in and say, okay, I want to go out and resync all those data structures. Okay, we've done our directory maintenance, made sure everything's cool. This is kind of like an FS check on Unix or Linux. And we can see, so the activity light is really blinking, and the I/O light is going on the, here's the I/O light, and we see the activity light on the disk drive. So this guy is, what it's doing is starting to build some of the system tables. Oh, okay. So memory resident tables set up, so it's set up all its data structures in memory. SL binding, SL stands for system library, so it actually builds the system as it's coming up, creating I/O processes. And the very last thing it's going to do is launch a special root process. System process creation is done. It's called Progen for the progenitor, and that's the root process of all the processes on the system. Okay, so in Bank 0, we use 13,107 words of memory. Okay, number of ATP terminal buffers for DRT8 has been increased to a minimum of 35. Okay, that's just a warning message. So unfortunately, there is not a Y2K. Here it is, 24. It's the end of June. It's June 28th, 2014, and I'm booting an operating system that's not Y2K compliant. So remember, this is the classic 16-bit stack architecture 3000. These have not been sold since the mid-1980s. So there was never a Y2K version of MPE built for these systems. There is a Y2K version of MPE-IX for the 32-bit RISC architecture machines, but not for this one. So what we're going to do is, this is kind of the beginning date of all of MPE, November 2nd, 1972. We're just going to take the default and say, yep, we're going to take that as the date. It's telling us it's log file number 5. And what we're seeing here is this particular system has a startup file which runs some commands. For example, it's streams 10 right here. That's telling us that we're going to do job submission through this pseudo device, which is configured as LDEF10. If we go back up, we can do this for reals. Let's go back up. Here we have, and here's in the boot process. Remember when we printed out the device configuration? We have this. Whoops, sorry about that. This trackpad on my Mac is kind of hard to highlight stuff. Okay, whoops. Come on. Anyway, device 10 here is a pseudo device. And so what we have to do is to enable batch job submission. We have to turn that on. we're starting spooling on the line, all our line printers, or all our printers that are in the device class LP. We aren't worried about JStart Safe. That's an artifact of this startup file. vmount, job security, outfence, that's just setting some parameters on the system so we can mount private volumes and people can log in. Those are various MPE commands. If we had disk caching enabled, we could actually start that, but we don't have it on the system. And then there's just some performance and networking kind of things that we can do. But what we have is, okay, so I apologize about this, but we're going to, so we are logged in right now. Let me just log out. So it automatically logged us in as operator.sys. That's what what's going on here. What I'm going to do is I'm going to log out. And when we log out, we see we had used 1 second of CPU. We were connected for 2 minutes. Here's the date, blah, blah, blah. We're going to see, since we're logged into a session, or we're going to log into a session on the system console, we're going to see our session interactions interspersed with system messages being sent out by MPE to the console. So that's what we see here is we got our logout message that we see on our terminal, but on the operator console, which we happen to be using at the same time, we're going to see these messages that would be going to the system console for the operator to see. Okay, somebody logged off on LDEF20, which was the console, and it's going to complain because I don't have the line printer turned on. It's going to whine about spooling, but I think that should be it. Okay, so to log in, we're just going to hit enter. It's going to give us a prompt. We can't enter help here. It's going to tell us, oh, I wanted a job data, blah, blah, blah. Or the hello command. This is not a good security practice, but anyway. So what we want to do is say hello manager.sys. And so manager.sys is the guy who's responsible for maintaining the system. So it gives us our login prompt, that kind of thing. And now what we can do is just enter various MPE commands like the list F is for list file, and it's going to list a bunch of files in the directory that we're logged into. We don't care about that, so stop that. We can do show me command. Oops, show job. There's only one job on the system, and it's a session. That guy there. So just for grins, why don't we build a job that just sends a message to the console here. So what we're going to do is we're going to say run editor.pub.sys. And sorry, my editor skills are a little rusty on this guy, so we want to say add. Okay, so record 1, we're going to say job. We're going to log on as manager.sys. And we're going to do the tell op command. We're going to say howdy from the test job. So what that's going to do is when we run this job or stream this background job, it's going to log in as manager.sys, then it's going to execute a command that sends a text string to the console. People could use this to say mount a tape or disk pack or whatever, or put this particular form in this particular line printer, that kind of thing. And then we're going to do EOJ. And let's see. Okay, sorry, I have to use my cheat sheet to figure out. Oh, come on. I could do this, but this is gonna. No, I don't want to do that. That's gonna. Okay, so :EOD is a special character string that basically says signal and end of data. Interrupt on whatever the console is, and so the programming board, you know what I'm going to do is, sorry, run editor dot sys. Usually you'd have user-defined commands set up so you wouldn't have to enter in this. I'm going to do help. Oh, explain, of course. Explain all. Oh, // Okay, so add. Sorry, I'm manager.sys. Tell op howdy from the test job. And then we have to say goodbye, EOJ. There we go. Okay, that's how we get out of. And so we're going to say text JTest. No. We just look and see, how do we say verify use, say text Q or not. Keep. Keep JTest. Yeah, snook it. Okay, let's exit. And then let's do listf JTest, comma 2. Okay, so again the listf command says list file entry from the directory. Listf JTest2, the comma, you can say comma 1, 2, 3, you'll print out different information. So what it's telling us is we just have this file called JTest. It has 8 no, that's not right. 8 records. Anyway, it's fixed. It's ASCII. Oh, okay. EOF is so it's going to have 4 records in it, 0 through 3, and number sectors, extents, maximum extents on disk. We don't care about that. Let's print out or list on the terminal. And to do that, we use the fcopy utility. So fcopy from JTest, and 2 equals. We're just going to hit carriage return because we just want to send it to the console. That's the default. Okay. So now let's. The way we submit a job in MPE is we use the stream command. So we just say stream JTest. Okay, that job's running. It's logged in. Oh, look at that. So, and I have a typo, TES. So, this is the message from the job, right here. Okay, so the job logged in, login from manager.sys on LDEV 10, that's our sudo device. Got this message from manager.sys from job number 1, and then job number 1 logged off. Okay, that's great. Now, let's see if I can actually... this will work. Let's see if Pascal... I'm pretty sure Pascal is loaded on the system. Just see if we can run a job. Let's just try this and see how this works. Okay. Okay, so it's going to ask for input. And output. Okay. And I'm just going to do a little program here. That line quote howdy from the Pascal program. And end, period. And then we're going to do EOD. So now it's going to, okay. So it went and it compiled this guy, and sorry, I'm having to exercise some brain cells here I haven't used in a while. There should be, okay, $old pass. So we should be able, I think we can run, I think it puts the binary in this, and again, MPE has some of these kind of goofy ways of doing stuff. That they have this concept of temporary files, which are not permanent files that just live for the session, but there's kind of these unnamed files like new pass, old pass, and so forth. So we're going to save old pass as test. And I wonder if we can run that. test. Oh, it's saved as a library. Okay. I'm going to have to look up and figure out how we can actually do the Pascal. But anyway, so that's, and we also have, I think there's Fortran 4, oops, run Fortran 4. Oh no, Fortran 77. I think we have Fortran 77 on the system. Oh, Fortran 2 FTN. Let's just run FTN. What that says. Okay, it's loading that guy. Okay, we do have Fortran 77 loaded on the system. Okay, it was expecting us to give it a program file to compile, but we didn't. So anyway, that's how we boot up a system. Why don't we actually go through a shutdown process here? And what I'm going to do is I'm going to log off as manager and shut down a 3000. We just hit enter. We're going to do Control A, which gives us an equal sign, and that prompt is from the, I believe it's from the progen root process on the system, asking us, you know, what do you want me to do? I'm controlling the whole system. And there's, let's see if that has help. Nope, doesn't. Let's try it again. Control A. So I know we have shutdown, so that will shut down the system. It's going to log everyone off, kill any bash jobs that are running, shut down all spool files, peripherals, and so forth, and then just close the system. Okay, and tell the hardware to halt. And so that's what's happened here, and now we're back at the firmware, and we see kind of the root set of firmware commands for the Series 37 here. Okay, take a look at my other 3000 videos, and I have some for peripherals also, and hope you enjoy it. Thanks.